Well, I was careless and my memory card filled up, but I don't want to redo all this. So I'm just going to kind of point. Actually, pretend you haven't seen these graphs down here. Okay, I'm going to reconstruct these graphs. I'll leave the construction up here as it is. But it's really going to be better for you. And I just did something ignorant, so let me fix that. Okay, so I'm going to position the x-axis over here as it was before. And we'll see why I did that. Okay, now all I've done is I've spaced 4 t values equally on both the x versus t and the y versus t graph. And then from each point I simply project up to the graph and over to the x-axis, then up to the graph and over to the y-axis, so that I get points here. Now these points, first one's here, second one's here, third one's here, fourth one's here, okay? They get closer and closer together because of the concavity of this curve. So my x values are going to be bunching up. They're also going to start to the right and move to the left. So they're going to look something like this. And they're moving this way, and I want to draw an arrow in this direction. Okay, the y values, well, they're pretty close together. And I'm not sure I did a really good job up here. They will be getting further apart because of this concavity. So I've got them drawn a little more accurately here. And the y values go this way as t increases. So for increasing t, the x values are now decreasing, the y values are increasing. Okay, now, when I did this graph before, I just blithely took this point and matched it up with this point and got a point right here. What's wrong with that? Well, this is the fourth point on this is the x point that corresponds to this t value. This is the y value that corresponds to this t value. Two different t values. That doesn't work. So even having drawn these little arrows and warned myself about that, I just didn't stop and think and drew the graph wrong. So, and I admitted it, but the memory card was full, the video didn't take. So there's no evidence that I actually did that. Okay, first y value with the first x value. And of course, again, first x value because that's the first t as we go from lesser to greater. The second x value is here, the second y value is here. That's going to give us a point here. Now third x value here, third y value here, and so forth. So there's my graph, and I can see that this graph is concave down, and I can double check to see that it should be concave down. These x distances are decreasing, okay? The y distances are increasing. So the run is progressively decreasing in magnitude, the rise is progressively increasing in magnitude, so the slopes are going to get bigger and bigger. The magnitude of the slope is going to get bigger and bigger as we move from here to here. Now the slopes are negative because the x's are moving this way and the y's are moving this way. But we have a bigger negative slope here than we have here. And you can see, if you think about it, you really do want to work to understand that how this spacing and this spacing gives us the downward concavity of the graph when the x values go in the direction they do. Okay, now over here things are a little more complicated, and I kind of jammed the graphs together a little bit because these x values, first they're increasing, then they're decreasing, then they're increasing again. How's that going to affect the graph? Well, I broke this interval from here to here into 8 equal parts, because I'm going to need a fair number of points to get a picture of this graph. And then I numbered the points, because it's going to get very confusing which point goes with which point, or which value on the x-axis goes with which of my t values. So I numbered them in order. First, second, third, fourth. So the first point here I've labeled as 1. There's my x value. The second point gives me an x value about here. I labeled that 2. Third point gives me an x value here. That's 3. Fourth point be here. Fifth point is back to the axis. Then the 6th, 7th, 8th, and 9th points will have x values here, 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 and then back here. The y values are going to be equally spaced because I chose a linear y graph. Now you can ask yourself how this would be modified if this was concave up or concave down. But what we end up with is 8 equally spaced, 9 equally spaced y values. Okay, so my x values are like here, that's 1, this is 2, this is 3, actually 3 is a little further out there, 3 is out here, and then 4 would be here, and 5 would be here. I didn't write 1, so I'll kind of write that in. I don't know if you can read it. And then 6 will be like here, 7 will be here, 8 will be here again, and then 9 will be back to the beginning, just mimicking the points here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, and back to 9. Okay, the y values will be equally spaced, linear function. So we have y values equally spaced between, let's say, here and here, and there are 9 of them, and I can get that by just subdividing, subdividing, subdividing. Kind of cheating, I'm not really measuring these off, but I could have, and it would have looked like this. Okay, so first y point, first y value is here, first x value is here, so our first point is here. Second y value, second x value is here, second y value is here, so I can project this point over here. There we go. Third y value is here, and it projects over here to match up with the third x value. And then the fourth y value is here, and it projects over and matches up. And then the fifth one matches up here. The sixth one is here, and you can see what's going to happen. Seventh one is going to match up with the seventh point. The seventh x value match up with the seventh y value. Eighth x value back here again matches up with the eighth y value, and the last one matches up. And now, connecting the points in the order that we constructed them, I get a curve on its side that's very similar to the curve I had going this way. Okay? Now, it's useful to go to all the trouble of sketching these points and so forth, but really what you're after is the trend. So we see x values gone right, then back to here, and then left, and here, while the y values just progress right along uniformly, and we don't really need, if we have a little practice. Of course, a stage in learning to do this is to actually construct it, but then look at it and see how we could have seen it without going to all the trouble to draw all the projection lines and so forth. How we could visualize the behavior of this set of parametric equations without actually having to draw this graph and draw this graph. How could we imagine this? And if we know it really well, we can do it. Now, our imagination is not going to give us a precise result that we can use to construct a fancy building. Okay? It's not going to give us a precise result we can use to design an industrial process. Okay? But it's going to give us a picture of the way this parametric equation develops and the way it works, so that we can then go to our powerful software and construct an exact curve, an exact surface in three-dimensional space, construct the projection of a four-dimensional object that might represent part of what it is we're trying to do. Okay, so we need to be able to do this sort of visualization. We don't actually absolutely need to, but we're going to be much more powerful if we can start with this idea and learn to visualize these things. Now, question, if y is increasing, well, y is concave up, what's that going to do to this graph? If y is concave down, what's that going to do to this graph? Think that through. I'm going to tell you in a minute, but see if you can think it through and imagine how that would modify this shape. Well, if y is concave up, these points are going to become more and more widely spaced, so that these points down here would be more and more widely spaced, which means that the part of the curve corresponding to this arch is going to be narrower than the part of the curve corresponding to this arch. So we get something that's narrower here and then gets fatter and comes all the way up here. Concave down, well, then this arch is going to be fatter than this arch. And there's more to it, more to the way these behave, but I do recommend that when you're working with parametric equations, you try to develop the ability to visualize them without having to draw them or without having, heaven forbid, to go to your calculator to visualize them. Now, some of them are so complicated there's no way to do it. You just can't hold it in your mind. But in most cases, it's fairly straightforward. And the things that you want to look at are just, are these points moving this way, or are they moving this way? Are they going back and forth? Okay, these points, they're going up, they're going down. Are they equally spaced, or are they spacing increasing? And it really doesn't take a long time to get a feel for that. So again, I recommend when you have a pair of parametric equations, sketch this graph, or imagine this graph and imagine this graph, and imagine what would happen if you went equal increments of t and how that would go together to give you this. You're going to have to do some sketching to start with, but after a while you're going to learn to visualize. Now, if you're really bad at visualizing, it doesn't mean you're a bad mathematician, it doesn't mean you're going to be a bad engineer. It's still worth being able to do it to the best of your ability with a reasonable input of time and effort. And that reasonable input, I think, would come from simply thinking this through for many parametric equations. You will very likely find that it becomes fairly natural to look at the equations in this way. Of course, you also have to be able to write these functions, okay, understand the shapes of these graphs.